Good afternoon, everybody. So the lesson for today is going to focus on functions. This is day 2 of functions. We've already talked about input, output, domain, and range, and now we want to put some more information with it. So what you see here is a picture of 2 different graphs. One is considered discrete and the other one is continuous. Take a second and think about what's the difference. Pause it. If you can't understand any of the words that I'm saying, it may help if you turn on closed caption. So hopefully when you took a second to pause it, you thought about discrete. Discrete is data, and the definition is there because I want you to write it down. Discrete is a set of input values that consist of only certain numbers in an interval. So when you see discrete data, it's most likely going to be dots. Or the best word for it is points, but discrete is going to be dots. Notice here at the top, when I wrote the word discrete, I put dots at the end. The other set of data that we can have is continuous. Now, continuous, on the other hand, is just like what it sounds like. It's gonna continue. It's you will have an arrow. It may be on one end, it may be on both ends. Who knows? But it just depends. Now, continuous data is a set of input values that consist of all the numbers in an interval. Take a second, pause it, write it down. I know that you don't have these yellow graph papers, but I do have some for you so that you can add this to your notes. What I did was we're going to take it to another level. So what you have here is some discrete data, your dots, and continuous data, this graph here. So what I did was I labeled things, and I want you to take a second if you need to and pause the video and write down the coordinates that you see here. I'm going to read them just in case if it's not legible. -6, -4, -3, 0, 2, 0, 6, 4. And on the continuous graph, we have -6, 4, 0, -1, and we have an arrow showing that it's going to continue going to the right as well as up. Pause it if you need to write that down. So what I want to do in taking it to the next level, we want to talk about the domain and the range of discrete versus continuous functions. So the domain, nothing new, it's just the set of all of the x values. Okay, and the range is going to be a set of all y values. So let's talk about what that looks like on a discrete graph. So for the domain, we will list every single x value. I'm going to underline those in purple. And what I'm going to tell you is going to help you when we talk about continuous. I want you for the x values to go from the least numbers, so far left, and continue to the right. And I want you to do the same thing with the range. I want you to start at the bottom and work your way up to the top. So for the domain, our values are going to be -6, -3, 2, and 6. The domain inside of brackets, and that's how we would write it: -6, -3, 2, and 6. You may see different variations depending on which book you use. For the range is going to be all of the y values, and the y's I'll just do in orange: -4, 0, 0, and 4. But watch the way that we write this down, because 0 repeats. We don't need 2 zeros. So what you're going to do is you're going to write from the bottom: -4, 0, and 4. It doesn't matter. We don't have to put 2 zeros. Leave that 0 alone. In life, do the same thing too. If you got friends that zeros, leave them alone too. Take a second, write that down. The domain in the discrete function in points, going from left to right. Like I said, do the same thing with continuous, going from left to right. So what we look at when we consider our domain for a continuous function, we look at how far we go left. Do this consistently and you'll get the answer right every single time. So we go as far left, remember domain is the x values, as a -6. Now we go as far right as, it's an arrow. What does that arrow mean? Does that mean that this graph stops? Or does that mean that it keeps going continuously? That means that this graph is going to keep going continuously, all the way off the page, all the way to, I don't know, Juvember. I don't know. But because it's going to go continuously, we will say that this graph goes to infinity. Okay? And then the reason why we did those inequalities with open and closed circles, because we had to know if it was how our solutions would look and what points it would consider or consist of. We go as far left as a -6, and that's a solid circle. So when I look at my inequality sign, I'm doing all of the x values. And x is going to be all the numbers that's greater than or equal to a -6. And it's going to continue going all the way close to infinity, but because you can't touch infinity, we don't have a less than or equal to sign there. Will it always be less than or equal to? Yes, as long as you go from the left, the lower side of the graph, to the right, every time. Pause it if you need to replay it. Or as the range for a continuous function, we look at how far down we go. So we start at the bottom, started from the bottom, now we're here. I'm just playing. But, and then we look at how far up we go. So this graph right here, goes as far down as a -1. And it goes as high up as 4. But wait, we got an arrow. Not only do we continue to the right in terms of the domain, but we also continue going up in terms of the range. So for that reason only, this graph is going to continue to infinity and beyond. If you're struggling drawing the infinity sign, don't you get frustrated. Turn that paper sideways, make an 8, and then turn it back sideways. Hey, rotate your paper. How about that for vocabulary? All right, so the range is our y values. Boom, we put a y in the middle. That range includes all of the numbers where y is greater than or equal to a -1, because it does touch a -1, and it goes as high up as infinity. And because we can't touch forever, we can't touch infinity, we don't put an equal sign underneath that. Now that's your domain and range anytime you have a graph. I want you to pause it if you need to write that. No, not if, because you need to write it down. Put it in your notes right here. Okay, so we talked about the domain and range for discrete and for continuous. Now, let's go here. For the domain, I got -6, -3, 2, and 6. Could I say that in my domain is also a -5? I mean, -5 is right there, but we don't have a point there. So the domain here does not include -5. It is those specific, only certain points that's included in the domain. And it's the same thing for the range. Even though I start at a -4 and I go up to a +4, can I include a -2 in there? I hope you said no. Why? Because a -2 is not one of my points or one of my dots on my discrete graph. However, for the continuous function, what this continuous line says, and I know you don't like these type of numbers, but this graph goes as far as -6 as far as the domain goes. That means a -5.95, a -5.88. Use that bell. But what I was saying is it includes a -5.95. It includes a -4, a -3, a -2.75, a -2.5. It includes all of those points continuously from a -6 all the way to infinity. And that's why we write it in this format, because it's every single x that's greater than this -6. And it's every single y that is greater than this -1. Okay? Now let's look at some practice problems, what it's going to look like. Jump into the word problems. What I want to do is show you, this is just an example. Discrete data involves a count of items, so only certain items. An example would be a car, a person, a suitcase. Like, you can't drive a half a car. You can't drive 3/4 of a car. Now, you could drive a car without a door, but that's a whole nother story. So a car is a whole thing. A person is a whole person. We can't say, oh, you walked up, you met 2.5 people. What are you talking about? So for that reason, we use discrete data. Now, as far as continuous data, that's going to involve data where numbers can be in between things. Like we look at your height. Your height is 5 feet 7 3/4 inches. The temperature could be 79.5, or right now it's probably 99.5 outside or something. Cell phone battery life. It's a continuous thing. It drains, hopefully by the time you wake up, it's at 100%, but look like by the time you go to the cafeteria, it may be 37.5. You're not going to get that much specific, but hey, that's how I go. All right. Take a second, write that down if you need to. Press rewind if you got to rehear. Third problem. Pause the video while you read it. This may seem jumpy, but this is what it is. John's gift card is loaded with $12. He plans to use his gift cards to buy books that cost $3 each. So the first thing that you can do is write an equation to talk about what's happening right here. Okay, so hopefully, now I'm going to pause it. You write your equation. Let's see what we come up with. Let me give you this much. Let's let X be the number of books that he purchased and Y be the balance on his gift card. Down. So the equation then, hopefully that you came up with, is that Y, the balance on the gift card, is equal to that $12 that he started off with minus the $3 per book that he's going to buy. Y equals 12 minus 3x. So a reasonable domain and a reasonable range then would have to be, he's starting out with $12. So before he buys any books, he has $12. Now, when he buys one book, he has already lost $3. So he got $9 left. Okay. When he buys his second book, he's going to have $6 left. When he buys his third book, he's going to have $3 left. And then when he buys his fourth book, he's going to have no dollars left. So that would be a reasonable range as well as a reasonable domain. So why is this function a discrete function? Because he can't buy half of a book. He got to go to the store and buy a whole book, or else he's going to be arrested. Okay, write that down. Now, I know you noticed that I closed the domain and range with those brackets, but that's one of the main differences between discrete and continuous data. When we have discrete data, we tend to use a bracket on our data points, and continuous is going to be an interval notation with some kind of inequality. That's your less than, greater than, equal to, greater than or equal to, less than or equal to signs. Now, what I want you to do is take yourself some good notes. And if you need help, you know Miss Gable is here for you. Okay? Miss Gable loves you very, very much. And I want you to do your best. Now, I'm going to tell you, you got to do your practice. You got to do work. Okay? How we get better? Practice. Talking about practice? We talking about practice? Yeah, man. Practice.